Assalamu alaikum. I am Dr. Sharmin Rahman, Associate Professor, Department of Anatomy, Abdul Medical College. Today I am going to discuss about microscopic structure of bone. Before going to microscopic structure, we have to know how the bone tissue is prepared for microscopic observation. Because of its hardness, bone cannot be sectioned with the microscope and some special steps must be taken to study it histologically. Among them, one of the main steps is microscope step section, by which we can observe the cells and organic part of the matrix, and for that we have to first preserve the bone by standard fixatives. Then the mineral is removed by immersion in a solution containing a calcium chelating substance such as ethylene diamine tetraacetic acid, which is also known as EDTA. The decalcified tissue is then embedded, sectioned, and stained as usual. Another type of section is round section. It is a manual process to make bone section by thinning the bone on a smooth surface. Here the mineralized state of bony tissue persists. Microscopically, bone can be divided into primary bone or immature or open bone, and secondary bone or mature or laminar bone. Primary bone is immature. It has abundant osteocytes and irregular bundles of collagen, which are later replaced and organized as secondary bone, except in certain areas. The areas are at sutures of the calvaria, insertion sites of tendons, and bony alveoli surrounding the teeth. Secondary bone tissue is the type usually found in adults. It shows multiple layers of calcified matrix and is often referred to as laminar bone. The lamella are parallel to each other and surrounding a small canal containing blood vessels, nerves, and loose connective tissue is called an osteon or Haversian system. This is a figure of compact bone, microscopic structure of compact bone, where you can see this is periosteum and these are osteon or Haversian system. The primary structural unit of compact bone is Haversian system or osteon. This Haversian system consists of Haversian canal, Bachmann's canal, concentric lamella, lacuna, and canaliculi. Haversian canals. Each Haversian canal surrounded by 4 to 20 concentric lamella runs parallel to the long axis of the bone. It is lined by a layer of osteoblast and osteoprogenitor cells and contains a neurovascular bundle with its associated connective tissue. In this figure, we can see this is medullary cavity, which are covered by endosteum, and these are osteon or Haversian system. In this Haversian system, we can see this is Haversian canal, which contains neurovascular bundles and its associated connective tissue, and are surrounded by 4 to 20 number of lamella. Volkmann's canal. The Haversian canals communicate with the marrow cavity and the periosteum and with one another through transverse or oblique Volkmann canal. These are also known as perforating canals. The transverse canals do not have concentric lamella, instead they perforate the lamella. In this figure, you can see these are perforating canals or Volkmann's canal, which also contains neurovascular bundles, and they are not surrounded by the lamina like the Haversian canal. But they perforate this concentric lamella to connect the two Haversian system with the periosteum and also with the marrow cavity. Now, concentric lamella, made up of fine collagen fibers. The collagen fibers are parallel to each other within each lamella. These are concentric lamella, this white color, which surrounds the Haversian canal. Lacuna. These are small spaces between two lamella and contain osteocyte. Canaliculi. These are fine radiating channels which connect the lacuna with each other and with the Haversian canal. They contain cytoplasmic processes of osteocytes. In this figure, we can see this is Haversian canal, which are surrounded by the lamella, and between two concentric lamella, there are presence of lacuna which contains osteocytes, and these are canaliculi, these thin spaces which contains cytoplasmic processes of osteocytes, and these canaliculi connecting the lacuna each other and also with the Haversian canal. So this is Haversian canal, these are lamella, and these are lacuna, and these are canaliculi. In compact bone, the lamella also exhibit outer circumferential lamella and inner circumferential lamella. Inner circumferential lamella are located around the marrow cavity. In this figure, we can see this is periosteum, this is compact bone, and this is marrow cavity. This marrow cavity is surrounded by endosteum, and these are inner circumferential lamella which surrounds the marrow cavity, and outer circumferential lamella are located immediately beneath the periosteum. This is periosteum, and just beneath the periosteum these are concentric lamella, that is outer concentric lamina, and this is endosteal surface or marrow cavity that is covered by endosteum, and these are inner circumferential lamella. We can see these circumferential lamina, that is outer or inner circumferential lamina. These are not surround the Haversian canal like this concentric lamella. As bone is being remodeled, osteoclasts resorb osteomes and osteoblasts replace them. Remnants of osteomes remain as irregular arcs of lamellar fragments known as interstitial lamella surrounded by osteomes. We can see these are osteomes or Haversian system, and between two Haversian systems there are another type of lamella present that are known as interstitial lamella. These lamella are formed when during bone remodeling, osteoclasts resorb the bones, and at the same time osteoblasts replace them. And during this process, some osteomes are resolved by the osteoclast, but there are some parts of the osteomes, that is some lamellas, are remain persist. These lamella are known as interstitial lamella that lies in between the Haversian system, and these are not encircle the Haversian canal completely. So, in a compact bone, we can see four types of lamella in the Haversian system, where the Haversian canal is surrounded by the lamella that are known as concentric lamella, and beneath the periosteum, these are outer or external circumferential lamella, and surrounding the bone marrow cavity, these are inner circumferential lamella, and in between the Haversian system, these are interstitial lamella. Now, spongy or cancellous bone. The bony plates that form the meshwork of cancellous bone are called trabeculae. Each trabecule is made up of a number of lamella, and spongy bone does not contain Haversian system. There are lacuna containing osteocyte and canaliculi containing osteocyte processes. Large marrow spaces present and filled in by bone marrow. This is histological structure of spongy bone. This is the calcified section where you can see bony trabeculae, bone marrow. These are osteocyte, lies in the lacuna, and these are osteoblast. So that's all for today. Thank you.